All right, so getting started on chapter 9, we're going to completely switch subjects from all of our polynomials and expressions and simplification and factoring, and we're going to focus on square roots. And just to kind of refresh our memory, I'm just going to give a little bit of an intro to some of the things that we've covered already in class, but want to make sure that we haven't forgotten them. And then we'll get into more of the homework in the next videos. So first of all, just some terminology. So when we look at all the different components in this expression right here, we have a little number that kind of goes into the crook right here, and that would be called the root. Now, if it's a 2, then we don't actually have to put it, because the radical sign here without a root in it would be called a square root symbol. So as we see down here, we don't have any numbers in this little crook, so we can understand it's implied that each of these we're taking the square root or the second root, okay? But sometimes there will be a number in there and it'll be higher than 2. It could be a 3 or a 7 or any other number. And that correlates to what the exponent would be on whatever the actual root of that number would be. So we'll talk about that in just a second. So this right here, the actual sign is called the radical sign, and then the number underneath the sign is called the radicand. So just some of the terminology that we went over before, and then another couple concepts that we've gone over, just want to make sure that we have a good understanding of, is in our first problem we have what we call the square root of 49. So what number multiplied by itself twice, because again, even though this 2 isn't here, there's an invisible 2 there. So what number multiplied by itself 2 times is going to equal 49? Well, 7 squared is going to equal 49, correct? So therefore, the square root of 49 would equal 7. So we don't have to put the square there because it's already right here. All 3 of these pieces are represented in this problem. We have a 7 and a 7, a 49 and a 49, and the exponent on the 7 becomes the root of the 49. All right, so just making sure that we understand what we're doing. So the exponent and the root correlate to each other. So in this case, we're taking the 7 and we're doing 7 times 7. And here we're saying, okay, what number multiplied by itself 2 times or 3 times or 8 times would equal whatever is underneath the radical sign? So if we have a negative out front, so if the negative is out front, then it's just going to kind of tag along till the end. So if it's out front, we just worry about what's underneath. So the square root of 49 would again just be 7, but because we have a negative out front that's going to tag along to the end, the answer to this one would be a negative 7. Now our last one is the square root of negative 49. So let's think about this. Can we have a negative as part of the radicand or under the radical sign if we're taking a square root or a 4th root or a 6th root or any other even root? Can that happen? Is that possible? No, it's not. So let's think about this. In order to get a 49, we would have to multiply a 7 times a 7 or a negative 7 times a negative 7. But in each of those cases, they will equal a positive 49. The only way we can get a negative 49 for our radicand is to have a 7 multiplied by a negative 7. But the very essence of having our roots and our exponents means it's the exact same number, and 7 and negative 7 are not the same. So it is not possible to have a square root or 4th root or any other even root to have it be negative. Okay, so if there's a negative underneath the radical sign and you're trying to take the square root of it, the answer will be not a real number. So this right here would be an imaginary number. And the imaginary number squared, as you see on my shirt, is a real number. So you're going to learn about that in another algebra class, not in here, but we just want to recognize the concept that we can't have a square root of a radicand, we can't take it if it's a negative radicand. So if the number under the radical sign is negative and we're taking an even root, so in this case the square root, that is not going to be a real number.